All of you, welcome to this YouTube channel. In this video, we're going to discuss about model analysis of cantilever beam I section. Here it is a model analysis of cantilever beam I section. The total breadth of the I section is 50 mm and height is 50 mm. The length of the beam is 250 mm. Here the metal properties are given. Young's modulus of the steel metal is 2 into 10 power of 5 Newton per mm square. Poisson's ratio 0.3. Density 7800 kilogram per meter cube. Here it is an answers. Select preference. Select structural. Click OK. Preprocessor. Select element type. Add. Again add element. Solid. Quad 4 node 182. Click apply. We need to select one more element. This solid brick 8 node 185. Then click OK. Plain 182 element is used to create a two-dimensional model of a given I section. After creating the two-dimensional model of I section, then go with the meshing. After completing the mesh part, element extrude option is there. For that we have to use solid 185. Here in this problem, the length of the cantilever beam is 250 mm. We can extend 250 mm length based on the element extension option. Close this. Next step is to assign metal properties, metal model, structural, linear, elastic, isotropic. Enter the Young's modulus value of steel is 2 e power of 5 Newton per mm square. Poisson's ratio 0.3 and click OK. Next one is density value should be enter for modal analysis. Density value, that is 7800 kilogram per meter cube is given. We need to convert it into Newton per mm cube. For that, enter the 7800 e power of minus 8. Then click OK. Next step is to creating a model. Modeling, create areas, rectangle, by dimension. For first rectangle, the x1 distance, y1 distance 0, x2 distance 50, y2 distance 10. Enter the value of for first rectangle. Enter the value of x1 distance as 0, x2 distance 50, y1 distance 0, y2 distance 10. Click apply. To create a second rectangle, there is middle portion. For that, x1 distance 15, x2 distance 35, y1 distance 10, y2 distance 40. Click apply. Further, to create a third rectangular, for that x1 distance 0, x2 distance 50, y1 distance 40, y2 distance 50 and click OK. So now we have created a 3 rectangles. Now 3 rectangles are in separate areas, so we need to create as a single area. For that, operate boolean, add areas, select first rectangular, second rectangular, third rectangular and click OK. So now 3 areas will be converted into a single area. Next step is meshing, size control, manual size, areas, all areas. Enter the element edge length as 4. Click OK. Mesh areas free. Select this area and click OK. At present, we have created a two-dimensional model. So we need to extend this I section for a 250 mm length. So for that, we have to go with this modeling, operate, extrude, elemental extension option. Select element type number as 2, that is solid 185. The material properties are same. Here we are not assigned a real constant, and enter the number of divisions 25, which means total length of the cantilever beam is 250 mm. So if here we are entered number of divisions as 25, then 250 divided by 25 you will get 10. So the element length is 25 mm length. Click OK. And then next step is areas. Select by XYZ offset. Select this area. Click OK. Enter DX offset extrusion. Enter the value as 250 mm length and click OK. So to confirm this from 2-dimensional to 3-dimensional, click isometric view. So here we are getting 250 mm length. So here we are getting 25 divisions each. So the each divisions consists of 10 mm distance from first to second divisions. So here only we are entered 25 divisions in the element extension option. Completed a modeling part. Next step is to assign the boundary conditions. So for that, solution, analyze type, new analysis. So here we are going to discuss, here it is a model analysis. Select model, click OK. Select analyze option. Select block cluster. Number of modes to be extracted should be 5, and then number of modes to be expand is 5, and click OK. Here the starting frequency is 0, end frequency is 100, and click OK. Next step is define load, apply, structural, displacement on areas. So here it is a cantilever beam. So we are selecting this area and click OK. Select all degrees of freedom. Enter the displacement value as 0. Click OK. Next step is solve current LS. Close this window and click OK. So here the solution is done. Close this window. Next step is to get a result part. General processor, read result, select first set, then plot result, deform shape, select deform plus undeform, click OK. So here it is for a first step, the frequency value is 5.37, the maximum displacement value is 0.357023. So here it is a maximum displacement at a frequency range of 5.37. To save this file, plot control, write meta file, select inverted white or black, Enter the file name as set1. Save this. We have entered a 5 number of modes to be expanded as 5. So we are going to get 5 different plot. For that, go to read result, select next set, and right click and replot it. So here in the previous one, the step is 1 and substep is 1 in the previous case. But whereas in the second set, here it is the subset is 2. The frequency value is 7.28. For that maximum displacement value is 0.350902. So here it is the second mode shape, second displacement of the mode shape. To save this file, plot control, write meta file, inverted to white or black, save as type as Windows meta file, enter the file name as set2. For our next step, read result, either we can go with the next step or we can go with by pick. So select this third step, read and close this and click replot. So here it is a frequency value of 15.8309 Hz. For that the maximum displacement value is 0.4722. To save this file, plot control, write meta file, select inverted to white or black, enter the file name as set3. Similarly, to get a fourth set, read result, by pick, select fourth one, read and close, right click and replot it. So here it is the frequency value of 30.01. The maximum displacement value is 0.361348. So here you get the different mode shape. To save this file, plot control, select write meta file, select inverted to white or black, enter the file name as set4. Save. To get a last result, you can select last set, or otherwise you can by pick, select the fifth set, then read, close this window, right click, replot it. You can get in this way also. So here the frequency value is, here is the frequency of 35.35 Hz. The maximum displacement value is 0.338752. To get this file, plot control, write meta file, select inverted to white or black, enter the file name as set5. To get the list summary, list result, detailed iterations. Here for the 5 set, 5 different frequency, then load step, substep, and community. To save this file, save as, enter the file name as detailed summary. Close this. I hope this video will be very useful. Kindly support this channel, like, share, comment, and subscribe. Thank you.